Well, hello everybody. As promised, I am going to be reviewing our Is It a Chemical Reaction Lab that you ran last week. Now, you should have taken home the actual paper document that you used during this lab, and you're going to need that today because you are going to be adding information from that paper to this new document shared through the Google Classroom. Things like your hypothesis, your data in data tables, observations, all of that is going to be placed into the electronic copy that I have shared with you in the Google Classroom. And if you were not here last week and you missed this lab, that's okay, because you could follow along with this video and get all the necessary information. What I would like you to do is pause this video now and go open up the electronic copy of the Is It a Chemical Reaction document in your Google Classroom. And then follow along. As we have time to pause and fill in each section, you'll be able to do that. So, any good lab starts with a title. We got that. Is it a chemical reaction? And then the purpose. So the purpose of this lab was to determine if a chemical reaction has taken place when certain elements are mixed with a copper 2-sulfate solution. And don't forget practicing with our mass change calculations. So we are trying to figure out what happens when elements are mixed with solutions. Following all of this should be the hypothesis. And this is important, okay, because we're trying to figure out what is going to happen when we're doing something. We need a hypothesis, that testable statement that predicts what is going to happen, right? Predicts the outcome to a question or a problem. In this case, we're trying to figure out what's going to happen when we throw some elements into a solution. So you need to write yourself a hypothesis. Now, if you were here, you already have your hypothesis written, and you can pause this old video and just type it right in. But if you weren't here and you're not really sure how to go about formatting your hypothesis, here's a little background information. Okay. We write our hypotheses in a very specific format. It's called the if, then, because format. And in this format, we are going to detail out the independent variable, the variable that you are changing on purpose, and the dependent variable, which is the measurement, calculation, observation that is, describing what is going to happen based on the independent variable changing. And so we usually see it made of these three statements. Like I said, the if, which is going to detail what variable you're changing, independent variable. The then statement, which is going to detail what will happen when you change the above variable. And a because statement, and this one is kind of important here because we're looking at explaining why you think the then statement is what's going to happen. And you're going to root this in some background knowledge, observations, or information that you have. So let's take that in a little. Hypotheses are written in an if, then, because statement. So if I change this, then this will be the outcome because of this background knowledge. So if we're looking at the way the hypothesis was set up for this particular lab, I gave everybody the if statement. And we pulled that right out of the purpose. If you remember the conversation, we said that if a piece of aluminum and copper wire are added to a copper sulfate solution, then, and you're going to fill this in, then what will be the outcome? Will both wires react? Will neither wires react? Will one or the other wire react with that solution? And then your because statement. Why do you believe whatever you said in your then statement? Why do you believe that you may or may not have something happen? So once you figure out your then statement, Your because statement is explaining why you believe that is going to be the outcome. Now, when we talked about this in class, we sort of brought ourselves back to, hey, the flame test. When we ran the flame tests, what did we notice? Because we had copper 2 sulfate as a chemical that we ran through the burner. And we noticed this phenomenon when we placed the little stick soaked in the solution onto the aluminum foil. We noticed something. So that became part of our because statement. Anyway, I don't want to lead you there. If you haven't run this lab or anything, it's okay if your hypothesis is wrong. It should never be changed after the fact. So if you were not here last week, or for some reason you forgot the paper I said 5 or 6 times to take home with you, then you should be writing your hypothesis right now. So go ahead, pause the video here. Take a minute. Either fill in the hypothesis you previously have written, or write your hypothesis now. Excellent. Moving into the actual lab here, the first thing you were asked to do was to mask the wires before anything should happen. So I have copper on the left with 0.58 grams, and I have my aluminum wire on the right with 0.19 grams. Be sure to fill that into a data table. The next thing we were asked to do was to then place these wires into a copper sulfate solution, and you needed to make some observations about those as well. And so what I have here is a lovely little time-lapse video. In the middle is the copper sulfate solution with nothing in it. On the left, right over here, is the copper wire, and on the right is the aluminum wire. And I let this take place for about 30-ish minutes. So you're going to want to make some observations here about what you're seeing before, during, and after the reaction, as was necessary in the lab. So again, if you have all of your lab data because you were here last week, you can simply go to the data section of the document I shared and put your data tables in there, put all that information in there, get all that right into that there document. And if you were not here, then you can sort of go back and forth through this video, make some observations about the wires before, the solution before, make some observations about the wires and the solutions during and after. Okay, so here is the video again. Oh, here is just a snapshot of the full after effect. So this was after the full 30+ minutes. Nothing else seemed to happen anymore at this point, and so I'm snapping a photo just to show you. Again, copper wire on the left, the control of just the solution in the middle, and our aluminum wire on the right. So go ahead, pause here, get all of the data into the data section, build those data tables to give you some good information that's easy to read and understand. And then come on back to the video when you're done. After everything was said and done with the reaction, I pulled the wires out. I wiped them off with a paper towel to dry them really well, which is why they're no longer coiled, just rolled up in these little sort of wire baskets here and thrown right back on the balance. And you can see that the copper's mass is 0.58 grams and the aluminum wire is 0.16 grams. Yes, I definitely cheated while doing my masses and used an electronic balance while you folks were using our single panned mechanical balances here. Could be a slight difference in our numbers, and that does not matter. And again, if you were here, you should be using your numbers and filling in your data table, whereas if you weren't here, you could be using my numbers and filling in my data. Now, all along the way, you should have been making some general observations. qualitative observations, observations that are looking at the quality or describing what is happening using words. So if we were looking at the solution, right, at the start of the solution, there was a really clear light blue color. And with the copper wire, the solution remained the same throughout. There was really no difference. However, with the aluminum wire, the solution changed color by the end, and it became a clear, barely blue tone. Now, the copper wire at the very beginning was a shiny orange metal. And throughout the entire experiment, nothing really seemed to happen. And at the end, once it was dry, with the exception of the way it was shaped, it looked exactly the same. It was shiny, orange, and metal looking. Now, the aluminum in the beginning was also a shiny silvery metal. And during, you could see some bubbling around the wire, and then you had a reddish brown substance attached to the wire. And at the end, after the aluminum was pulled out and it was dried, the aluminum wire was no longer really shiny. It was much more dull. And if you ran your fingers around the wire, you could tell that it seemed really thin in comparison to the way it felt when it started. In terms of our quantitative data, right, data that measures quantity, so numerical data, right? We're looking at the two different wires because we didn't mass the solution, we only massed the wires. And you had your initial mass, so for copper was 0.58 grams and for aluminum was 0.19 grams. And the final mass for copper was 0.58 grams and for aluminum was 0.16 grams, which means copper had zero change in mass and aluminum had a negative 0.03 gram change. It's important to understand when calculating your change in mass, you're looking at the final mass minus the initial mass. And that's important because if you get a positive answer, a positive change, that would mean your mass increased. And if you got a negative change, that's going to mean your mass decreased. And I'd like to think that if you got a 0, you'd understand that there was no change. Moving on. Please make sure you have all your data tables filled in and in the data section of the document shared with you via the classroom. Last but not least, you are going to use all the information that you had gathered in your specific lab in order to answer these 3 analysis questions. Now you've got to answer these bad boys in full sentences. That means, could you please use proper punctuation, mechanics, and grammar to start a sentence with a capitalized letter? Don't you just rely on that there autocorrect, okay? Think about the quality of your work that you're going to be turning in and use as much information as you possibly can. I want you to make sure to explain what kind of evidence from the experiment supported that a chemical reaction took place. I want you to explain the change in mass for both wires and why you believe there was one, if there was. And I want you to think about the lab that you ran, or even the lab you just watched. What kind of improvements could be made to ensure that there might be better results that come out? All of these can be answered whether you were in the lab or watching the lab. Now, once you have this whole document filled out, you have answered these questions in your specific lab document. I want you to go to the Google Classroom and I want you to open the spreadsheet for our class data. We're going to be looking at comparing everybody's change in mass data for both the copper wire and the aluminum wire. And then we'll go from there. Have a great day.